Today we are using a procedure called completing the squares, which is another method to solve a quadratic equation, which this procedure can be done with algebra tiles. Here are some points to review. So go ahead and pause the video to read these points, and then when you're done, go ahead and unpause the video. To begin, I have a side note for the key of algebra tiles. So let's go ahead and see what we have for algebra tiles. We have a 1 tile, an x tile, an x squared tile. So let's begin. We are solving for x squared plus 4x equals 5. Let's represent this equation on the equation mat. So we have x squared plus 4x. And the way that we are arranging it is that we're forming the tiles in part of a large square. And if you noticed, there is a piece missing of this large square, and I'm going to go ahead and sketch that so you could see that more. We'll come back to the left side in a minute. Let's go to the right side of the equation. We have 5. So let's go ahead and put 5 tiles, 1 tiles on the right side. So that's 1, 2, 3, 4, 5. Now, this is what is representing on this equation. So let's go ahead and see how many 1 tiles we need to complete this large square. So it's 1 tile, 2, 3, 4. Now we have the whole large square at this point. We added 4 1 tiles to complete it. Now what we add to one side, in order to keep the equation balanced, we must also add it to the other side. So we're going to go ahead and do that on the right side. So we're adding 4 1 tiles. And that makes now on the right side 9 1 tiles. So on the left side, our trinomial is x squared plus 4x's 1, 2, 3, 4 plus 4, 1, 2, 3, 4. Now this trinomial is a perfect square. Now let's go ahead and write what's on the right side. So we have 9, and we're solving for x. But before we do that, if we noticed here, we have x plus 2, x plus 2. So we're using the length and the width of the square, so we can rewrite the area expression in a factored form, which is x plus 2, all of it squared. And let's go ahead and bring that 9. And what we're going to do, we're going to square root both sides to solve for x. So we have x plus 2 equals plus and minus 3. And we're now just solving simply for x. So we're going to subtract 2 on both sides. So we have x squared equals 1, or on this side we're going to subtract 2 as well, and that's x squared equals negative 5. So our answer is x squared equals 1 or x squared equals negative 5. So now on our second problem, we have a word problem. We have Griselda is designing a small rectangular patio for her dollhouse. She has enough craft sticks to cover 7 square inches. She wants the length of the patio to be 6 inches greater than the width. What dimensions should she use for the patio? Now, let's go ahead and underline the given information. We have, she has enough craft sticks to cover 7 square inches. We also have, she wants the length of the patio to be 6 inches greater than the width. Now, let's go ahead and set up an equation for the area of a rectangle equal to 7, which is the area of the patio. So we're gonna let x be the width, and we're gonna also let x plus 6 be the length. Now, using the formula of area of a rectangle, we have length times width equals the area of the patio. So we have x plus 6 times x equals 7. And let's go ahead and distribute this x. So we have x squared plus 6x equals 7. Now what we're going to go ahead and do, we're going to use our equation mat to represent this expression. So we have x squared plus 6x, and again we're still trying to create that large square. So now I have 6x tiles on here, and again we're missing a part of the square. Now let's go ahead and go to the right side of the equation. We have 7 tiles. So I'm going to go ahead and put that. I think I count 1 too many. There goes 7. So what we're doing now, we're going to go back to the left side of the equation mat, and we're going to go ahead and find out how many 1 tiles it takes to complete the square. 1, 2, 3, 4, 5. So the missing part was 9 1 tiles, and now we have a perfect square. So since we added 9 tiles on the left side, we must also add them to the right side. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So our trinomial in this case is x squared plus 6 x's, 1, 2, 3, 4, 5, 6, and 9, and we have a total of 16. Now let's go ahead and solve this. Now we see we have x plus 3 and x plus 3. And again, we're using the length and the width of a square, so we can rewrite the area expression in a factorial form. So that's x plus 3, all of it squared. Let's bring down that 16. We're going to square both sides. So we have x plus 3 equals plus and minus 4. And let's go ahead and solve for x. So I'm just going to do subtract 3 on both sides. So that gives me x equals negative 7. And let's subtract 3 on this side as well. So that's x equals 1. Now, if you reflect on something, the length could never be negative. So we know that that will not be our answer. So now we know that the width is equal to 1. And we know the length is 1 plus 6 equals to 7. So the width is 1 inch and the length is 7 inches. Now, I want you to try these problems at home and bring them to class for tomorrow.